The next thing that we're going to look at is the factor theorem. The factor theorem is a quick way of finding simple linear factors of a polynomial. The factor theorem states that if f of x is a polynomial, then if f of x equals to 0, then x minus p is a factor of f of x. You need to remember this, and if x minus p is a factor of f of x, then f of x equals to 0. This is just a reverse of the first thing that we mentioned. You can use the factor theorem to quickly factorize a cubic function. First, you substitute values into the function until you find a value of p, so that g of p equals to 0. Then you will divide the function by x minus p, and write g of x equals to x minus p times ax squared plus bx plus c. This is actually a bit similar to the example that we did before. Then you need to factorize the quadratic factor, if possible, to write g of x as a product of three linear factors. Let's look at an example in which, given that x plus 1 is a factor of 4x to the power 4 minus 3x squared plus a, and it asks us to find the value of a. So firstly, we're going to write the polynomial as a function. So f of x equals to 4x to the power 4 minus 3x squared plus a. Then, by using a statement from the factor theorem that we looked at first, which is x minus p is a factor of f of x, so f of p equals to 0. So p equals to -1 in this case. And we'll let it to equal to 0, and so we get that 4 minus 3 plus a equals to 0, and so a equals to -1. And let's look at a proof to this theorem. In order to prove that x minus p is a factor of f of x, and so f of p equals to 0, so we will look like we know that g of x is a polynomial expression, and we know that x minus p is a factor of f of x. Therefore, f of x would equal to x minus p multiplied by g of x. Therefore, we're trying to prove that f of p equals to 0, and so we will write that f of p equals to p minus p multiplied by g of p. And you know that we're going to substitute the value of x into p, so p minus p equals to 0, and 0 times g of p is 0. Therefore, f of p equals to 0. And the proof is done.